Okay, a small quick video. I wanted to step through DO's code a little bit just so you can see how it all works, really, and also a little bit of fault finding. The code is, I'll just show you the pathway for it just so that you know you've got the right one. It's in the early bird folder, DOv2, Arduino sketches, and it's called V2 RC code self-balancing number 2. Use this one, and then there's codes on there. So that's the one that I've tweaked, and I'll just step you through what the code is. So in the first instance, what you've got here is you've got a little bit of code. These are really useful. You need to check these connectors. So this is where the direction pin, where the speed pin goes to on the Arduino. So what this first bit is really just to check your wiring. Make sure you've got the right wire to the right wire, that you've not mixed them up or whatever. They're not necessarily sequential. So DR1 on the motor controller goes to pin 13, PWM1 goes to pin 12, DR2 goes to pin 11, and PWM2 goes to pin 10. So that's a reference on where they actually connect to on the device. Okay. Then you've got a few bits and bats which you don't really necessarily need to change any of these. You can tweak a lot of it on the remote, so we'll leave these as is. So we'll continue down with some clever stuff that sets up all the balancing, and then the other bit here, which is pin 1 and pin 2 go to is 3 and 4, and what there is that they're the input for the remote control. So that your input for RC1 goes to pin 3 and RC2 goes to pin 4. So that's typically your channel 1 and your channel 2 and your tank mixing, and they go to pins 3 and 4 on the Arduino. A little bit of iteration there where it hangs on a little bit, sets some motor speeds up and sets some default settings, which you don't need to worry about. It then goes through this bit of code here. All this really does is get everything started, and in the setup it then starts to measure the first input from the remote controller. Now what you've got here is a little statement that all this does really is it waits until the output of the remote control is between 800 and 2200. So typically an RC unit will output 1500 in its default position, and it measures it and then it makes sure it's between those numbers. If it's not in between those numbers, it won't start, so it'll just sit there, the motor won't drive. The reason for that is if it starts without any RC signal coming in, the motors it will receive 0, and therefore the motors will run at full speed and it'll just start flying off or spinning. So that's just a pause until it gets a signal. Then we move into the main program. The program is fairly simple really. What it does is it first of all measures duration. Just before we actually get into the main program, one of the things I actually should have mentioned is there's a line here. When you want to first set it up or you want to debug, if you take those first, when I say uncomment, it means deleting those first two, and that line then becomes active. What that line does is it starts the serial port. So on the Arduino, it allows you to see some debugging. The reason I keep it commented out when it's running normally is the serial port naturally then slows down the whole process, and therefore you don't get as good a balancing. So when you're first debugging and testing, you can delete that and you can start to switch on different readings as you go through, so you can check to see what's actually coming out from the Arduino, and then when you finish, put those back in again. Don't worry about the code, as long as you just save yourself a couple of copies of it so that you don't get yourself into a muddle. But just take those out, that'll enable your serial port. So what the main code does is, first of all, it measures what's coming from the remote control. So those two pins, which are, as we showed in the earlier, they're pins 3 and 4. So there we go. So what it starts to do is it's measuring the RC that it's receiving from 3 and 4. There is a couple of, again, debugging things here, which you can remove these two little the uncomments at the beginning of it, and what that will actually do is it will print those two values. Okay, so you can actually start to look at those two values to see, make sure that you're getting some sort of value on there if you're not sure that you're receiving the signal from the Arduino. So, and the way that works is you uncomment the serial further up, you uncomment the numbers that you want to see. You then need to obviously upload the code to the Arduino, and then when it's uploaded with the cable connected, and at this stage you don't actually need to turn DO on because the power from the cable will do most of the readings. If you click on Tool and Serial Monitor, that's where you'll start to see the output. Make sure the serial monitor is set to 9600, it's in the code, but it just gives you the chance then to start to see some of the measurements that are going on. So you can then read those, and you want those to be by default around 1500, and then max out to around 2000, 2200, and minimize to about 800 or so. Okay. So what happens then is there's this piece here, and what this really does is it maps those two outputs to something that the speed controller can understand. So basically all it's doing is taking those sticks and making it into a motor speed. And again, if you want to check that mapping, you can uncomment these out and you can have a look at these. Now, it says here, warning, do not use any delays inside the loop. Yeah, so you just want to keep this running as fast as possible, so don't need to add anything. Load of clever stuff on here that reads the accelerometer, the balance chip. That calculates a PID, and then it'll start to give you all of the balancing stuff. So if you come down to here, one of the very useful ones that you can do is you can read the absolute value there. Now, what the absolute, sorry, this total angle here, what the total angle is it's that's the angle that your DO is actually at. So when you first set your DO up, the IMU, the balance, may have an angle that isn't perfectly zero. For whatever reason, it can be where you are on the planet can affect it. It can be the manufacturing of the IMU, and it can also be the angle that DO rests at. So it might not be 0. It might be -1. It might be 1. It could be -10. It could be 10. It could be anything really. So if you you can correct that if you want to by trimming the RC. But if you the first thing you do when you fire DO up, have a look at what that total angle is when he's at rest, when he's sat there in the middle. And again, you don't need to have powered the motor up on this. What you can do is just put the Arduino USB connection in, connect it to your PC, run serial monitor without him powered on, and his motors won't run, and just let him rest and see where level comes in at, and make a note of that angle. Okay, because what you can do then, you see, is that total angle. If you go right back to the top, there is a there's a little one here called float angle equals minus 0.3, and that's the value that you can change. So in an initial setup, what you would do is you would first of all, step 1 would be, once you've got everything up and running and you're happy that the hardware and the electronics are working to the point, step 1 would be turn him off, plug the Arduino in, take out them two little comments out. So you start the serial, scroll down a little bit, get down to the next one, which tells us our total angle, which is this one here. Take out those two little comments there. Once you've done that, upload the code into into DO, run the code, let it run, let it go through power cycle, go into Tools and Serial Monitor, and you'll see the angle that it's measuring coming out on there. Take a note of what that angle is, what it's at rest. So whatever number it is, I said it shouldn't be more than 10 or minus 10. It shouldn't really go outside of those values, but typically it might minus 7 or whatever. It might even be as small as 0. And then what you do is you go back up to the top and you change the desired angle to that angle. So that then accommodates for anything where your IMU might be out. Okay. Once you've changed that to the desired angle, you go back, you re-comment in your serial starting, where it says serial start, if I can find it there. Yeah, so you re-comment that, so that doesn't work. And then you re-comment out that print angle where this bit here, so that doesn't work. So you basically put the sketch back. The only thing that you've actually changed is that desired angle there. And then what that's done now is it's customized it specifically to your IMU settings. Okay. So continuing down the code, some more clever stuff that does all of the balancing. And then this statement's quite useful as well. So what this does is it takes the motor speed that's come out of all of the balancing clever stuff and remaps it to a number between 0 and 700. The motors go minus 255 to 255, but so 255 is the max. I use 700 because it's kind of it gives it a bit of extra oomph when it's on the balancing code. So it should work by default, no real reason to change it. But if you want to, you can have a little tweak around with that 700 number. If you reduce that, it'll make the harshness of the speed compensation go down. So it'll be less strong on the balancing. And if you push it up, it'll start to increase the harshness of how it compensates just purely for the balance. So, but 700 is a good default, and as I say, I wouldn't mess with it unless you do want to play around with some of the tweaking. Then some more clever stuff. It really just starts to set the speeds. This is really just where it will decide whether it needs to go forward or backward, depending on where the angle is. Then you've got the motor speed. So this is where it starts to take. It takes the actual speed that comes from the RC, and it literally adds on the adjustment speed that's coming out of the balance. So that just really meshes the two together to create the speed. And obviously this runs thousands of times a second. It adjusts the speed depending on the balance on what it's getting from the RC, and that's really what will start to drive your DO. And again, a few more serial prints if you want to see what comes out at that point. And then what you've got here is you've got some more statements that make sure that the motor's going in the right direction. And then the very, very final bit at the bottom here is there's a final serial print, so you can check that. And then what you've got here is the actual, this is the actual control that sends that information to your motors. So this one is the direction, and this one is the speed for one motor, and this is direction, and this is the speed for the other motor. And that's it. And then it just loops straight back to the beginning. So the code in here then goes straight back to here, remeasures, does all the clever stuff around balancing, creates a value and speed value. Most of the code is around this balance, adds a speed value to the actual value that's coming out of your RC, and then what it does is it effectively sends that to the motor. It just keeps going round and round. But hopefully that was useful as an update on the latest code. So the key takeaways out of this are: when you first set your DO up, enable serial print. Have a look at where it's balancing at the moment, currently on that total angle. So let's have a look at what it's measuring at rest. Go back up to the top and set your desired angle to that total angle. So tell it where rest is. Put your serial connection back commented. Put your print where it prints that total angle back commented. Upload the code, and off you go. If you hit any issues, what you can do is you can use that serial print and uncomment at various parts to check. Let's have a look what's coming in from the RC to make sure it's receiving the signals. Let's see how it's mapping to the motor speed, so you can start to dig into the numbers to see what's actually going on. But that should get you started on the code. Hopefully that was useful.